What I'd like to do now is introduce our first keynote speaker of the event. So Kishore is one of the co-creators of Apache Pinot. That's a fascinating story. We'll talk more about that in the panel tomorrow. He is one of the co-founders and the CEO of StarTree. He happens to be my boss also. I would like to welcome to the stage Kishore Gopalakrishna.
Thank you, Tim. Good morning, everyone, and welcome to the world of real-time analytics. This is a topic that's very near and dear to my heart, and I'm so glad to be able to share my thoughts with you all today. As I stand here, I'm kind of struck by the irony of the situation. Back when I started my career, I was a big C++ fan. I never wanted to work on Java. In fact, I never wanted to build a database either. And before I started Apache Pinot, I didn't even think real-time was a thing or we even needed one. But over the past 2 decades, I have built like hundreds of Java applications, built multiple databases, and here I am talking about the rise of real-time analytics. The reason I bring up this story is to emphasize the power of decision-making in our life and how some decisions can actually change our lives completely. We all make decisions. In fact, if you're not familiar with this, we make 35,000 decisions in a day. That's almost 1 billion decisions in a lifetime. And if you do the math, that's almost one decision every 3 seconds. Obviously, all these decisions are not created equal. For some of these decisions, the blast radius is very limited. It might just impact us or our family members. But some of them have huge impact in terms of the decisions. It's very important for us to get some of these decisions right, especially the ones that have higher impact. So that leads us to the most important question. How are we all making decisions today? Let's go back a little bit and see how this decision-making process has evolved over years. Historically, we all have made decisions based on intuition, very similar to the decision that I made about Java or C++. We just take into account our past experiences and the knowledge that we have accumulated so far. However, with the advent of analytics, this started changing, right? We started making decisions based on data. Even then, this data was limited to certain people in the company. The execs or the CXOs, only they had access to this data. But in the last decade and a half, even that started changing. A lot more people within the company started having access to this data. In fact, this is exactly the reason why I changed my view from C++ to Java, because it was obvious that a lot more people wanted to work on Java because of the ease of use and the modularity and the ecosystem and the power of ecosystem. Similarly, that's what made me change my decision about real-time as well, because looking at the business KPIs at LinkedIn, it was pretty obvious to me that real-time is inevitable. Some companies are still making this transition, going from intuition-based, making decisions based on intuition to making decisions based on data. But this is not enough. What about our users and consumers? What about the data freshness on which we are making the decision? These are two very important factors. Let me tell you why. Because if you kind of look at the entire world's population, the execs and employees, we account for really very small percentage of this population, right? There are billions of people in the world, and they're all not making decisions based on data. The second part is the world is constantly changing. So the decision that we make on data, based on data, it has to be accurate. That means we need to take into account all the changes that are happening in the world. The view of the world that we know about from yesterday is already changed a lot. So we need to make sure that we take into account all these changes. Let's take a quick example. Even though this seems like a lot, we are already doing this. Like, let's take an example of the food delivery app. We all have been placing orders online in the last few years. If we kind of go back, this was very different before. If we had to place an order, we would call a restaurant, we would even call multiple restaurants and try to get the wait time and then pick the right restaurant. But with the advent of all these food delivery apps, this has changed completely. If you look at every persona on this slide, we as consumers, we are now have access to the serving time, to the most popular items nearby, all this on our app. And we are making decisions on which restaurant to pick and the food that we need to order based on this data that we have access to in real time. The restaurant owner, imagine him having access to a real-time database, real-time dashboard, and being able to track the serving time, and he knows that the eater on the other side is making decisions based on this. So he can now look at the serving time, make sure that the customers are getting the best experience, can hire more workforce if needed. The riders are getting instant feedback from their customers. They need to make sure that their rider score is pretty good so that they get their bonuses paid. At the same time, if you look at from the other side of this food delivery app, the company that is providing this app, the internal operators and the analysts, they are having access to this data as well. Now they can monitor the supply and demand in real time, and they are able to react to the changes very quickly. There is another way to look at this. If you kind of look at the data itself, it has a shelf life. We may not realize this, but the data loses its value very, very quickly. Let's take an example. Let's say we search for a pizza on the food delivery app. The value of this event is the highest when it happens. Like if you look at it from a food delivery app perspective, they have to act on this very quickly to make sure that the user makes a decision and places the order. They could send recommendations for the best pizza places nearby, or they can even send discount coupons. But if you kind of get to know about this event a few hours later or even the next day, that's a missed opportunity. The existing batch stack that we have are not really built to capitalize on this value of data. In order to solve that, we really need this real-time stack so that we can act on the event when the value is at its highest. It allows us to make accurate decisions because, as I said, the state of the world is changing every second. Not only that, it allows us to react to the unexpected events. Let's say there is a sudden surge in the food demand, then the food delivery app or the provider can actually make some adjustments accordingly. Now that leads to the next question, which is very controversial, and pretty much everyone has an opinion on that, is what is real time? Is it instantaneous? Is it like milliseconds? Is it seconds? Is it minutes? In my opinion, that's not the right question to ask. The right question to ask is, how quickly should we react to make sure that we are capitalizing or maximizing the value of that event? Now, if you kind of ask that question, now you can say, like, depending on the use case, it can be milliseconds, it can be seconds, or even minutes, or even hours in some cases. But it's really important for us to approach from the value of that event versus just debating on what is the exact time is that means real time. I know that was a lot to process, but I want to give another view of this. If you kind of look at this axis of batch and real time and internal and external, what we are doing today is really addressing a very, very small percentage of the market. It's really that blue quadrant out there. We are missing out on a lot of different decision makers who want to have access to data to make decisions. Now let's take a look at how do we get from the stack that we are in today, which is focused purely on batch and internal, to get to real time and user facing. Before I continue, I want to say one thing that is not a solution. Real time is not equal to micro batching. This is something that requires a big change in our mindset. We cannot simply take our existing stack and then turn it into a real time. This is very similar in terms of how the modes of transportation have evolved, right? If we kind of wanted to go longer distance, we simply didn't take a bike and added more gears to it and turn it into a car. Similarly, we didn't take a car and added some wings and turn it into a flying machine. This is very similar because the reason why I bring this up is many companies have tried this. They've taken a batch system and say, oh, we need to now solve real time. Let's run it every hour. Let's run it every 15 minutes. And this has actually resulted in a lot more inefficient resource utilization and it is actually proven out to be much more expensive for the company. Not just that, they didn't even get the results that they wanted in the first place. So my humble request here is, please don't do this. Having said that, let's go back and then look at how did we get here. Most companies start off with a simple database. This is pretty much how every organization starts. Obviously, after some time, they cannot run analytics on this database. So they do an ETL, get that into a data lake or a data warehouse. And then you have your internal employees or internal users use their favorite BI tools to get access to this data and then perform analytics. But the challenge here is if you kind of look at the time it takes to go from events to insights, it can be in hours or days, depending on the pipeline that we have. This is what we want to change. And the first thing that we needed to change was have the ability to introduce an event source. And the reason why we needed this is, as I mentioned earlier, we want to track every change that is happening in the world. That means being able to ingest millions and trillions of events within a second. And databases were not built for this. The cost of logging an event is very, very expensive within the traditional databases. This is where systems like Kafka, Kinesis, Pulsar, Red Panda, all these things emerged, which allow us to ingest millions and trillions of events within a given second. After that, we needed some changes to the real-time processing structure as well. Because the existing ETL systems were not really built to process at an event level. They were taking the snapshots, or they just like the file system abstraction. So they would be processing events, processing data at a batch level. So this is where systems like Samza, Flink, K-Streams, and others have emerged that allow you to process the events as soon as they happen. But something stopped after this, because even after this, people would take this data and then put it into S3 or the data warehouse or the data lake. It kind of completely defeated the purpose on why we started this revolution in the first place, or the real-time movement. This is where we have a missing piece, and we need that real-time database that allows you to capture the events as they come in and then be able to serve it to the end users. Not just your internal users, but to your external users as well. This helps you to complete this journey from event to insights, and you can go from milliseconds to within milliseconds or seconds. And one thing that I do want to call out here is the expectation of your external users is very, very different from the internal users. Your internal users are a lot more forgiving, but your external users are not. And you want to make sure that the latency that they get is very quick and very fast. Also, the order of magnitude for our external users is very different from the internal users. So that leads us to the next question of which database is the right one. Now, there are like hundreds of databases out there. Which one do we pick? In fact, this is the first question that we asked at LinkedIn when we were about to build Who Viewed My Profile. And we went on and picked Lucene, which is a search technology. We had an internal technology at LinkedIn which was built on Lucene. And we needed 1,000 nodes just to serve Who Viewed My Profile at LinkedIn. And in spite of having 1,000 nodes, the user experience was really bad. And it was a nightmare for us to operate this cluster. So we had to do the same thing that I mentioned earlier. We had to take a step back and completely rethink everything from the first principles. And that's when, after years of exploration, we built this database, Apache Pinot. It was purpose-built for real-time and user-facing analytics. It was built for speed, and it was proven at scale at a lot of different companies. Every transaction at Stripe, every page view, every click that you do on LinkedIn, every order that you're placing today on Uber Eats, all of them are flowing through Keynote today. And it's serving almost 200,000 queries per second. Just to give you a comparison, if you look at all the cloud data warehouses out there today, their average queries per second across all their customers is 1 query per second. And LinkedIn, just at LinkedIn alone, Pinot is serving 200,000 queries per second. And once we had this was a game-changing thing for us at LinkedIn. We were able to go from 1,000 nodes to 75 nodes. And in fact, when we were making this transition, we went from 1,000 queries per second to 5,000 queries per second. That's like 45x improvement in efficiency. And that was really a breakthrough for us. Now, if you visit LinkedIn, you look at any data point on LinkedIn, any numbers, everything is being powered by Apache Pinot. It's not just that. In the last 2 years, we have seen tremendous growth in Pinot adoption. You can see companies across various sectors, retail, fintech, logistics, media, comms, SaaS, all of them leveraging Pinot, both for their internal use cases and external use cases. For example, Walmart, every order that you place on walmart.com, Citibank using it for monitoring market risk, WebEx, every WebEx call data is coming into Pinot. Similarly, Wix, which is one of the biggest web hosting companies, get all their web traffic, page analytics into Pinot, and they're able to provide real-time dashboards to their customers. That's not it. Even companies like Eero, which is in the IoT space, or Morgan & Morgan, which is actually a law firm, we are seeing across multiple verticals, across various different sizes, all of them are adopting Apache Pinot. One industry that I do want to highlight is the SaaS companies. What's happening with the rise of SaaS companies is they are collecting a lot of data from their customers, and that is something that they want to provide something back to their customers as part of data product. So it's becoming very critical for SaaS companies to provide analytics back to their end users. And that's one of the places where Apache Pinot is widely being used. Let's talk a little bit about the community. Community is at the heart of Apache Pinot project. And the growth in the community has been fascinating in the last few years for us. And again, none of this would be possible without the fantastic community that we have. Over the last 3 years, we have grown our Slack community from just starting from 100 to 4,600 people right now in the Slack community. Our downloads have skyrocketed going when we started tracking 3 years ago to almost 6 million downloads today. And the beauty of this is every day we come across new and exciting use cases that our users are sharing in our workspace. And none of this was something that we had actually thought about when we built Apache Pinot in the first place. It's really exciting to see that. So that leads to the next question is like, why did we build a new database? What was the main reason for that? And once we went back and then looked at the existing solution, which was based on Lucene, we could classify the problems into 3 different dimensions. The first one was the freshness. This is very important. It goes back to the point that I made about micro-batching. It's very important for us or any database to, as soon as an event comes in, it's able to serve that. You don't want any latency, additional latency in terms of micro-batching or indexing that data. Not only that, we even went one step further. Pinot was actually one of the first databases out there which said you don't need another ETL layer in between. You can simply point at your source, which can be Kafka or any other event sources, and it directly pulls data from that. So you don't need another layer which reads from Kafka and writes to a database. We did everything to make sure that we don't introduce additional latency in the data flow. The next part is the latency. It has to be interactive. Because when you look at decision-making process, it's not a single-step process. It's an iterative process. You first ask one question, you get the response back. Depending on the response, you're asking another question. So it's an iterative process until you get the answer that you want. But if your latency is very high, you don't really feel like making these decisions or even interacting with the system. So if you really want to make this analysis at the speed of thought, you need very, very low latency from the database. Last but not the least is the concurrency. Because one of the things that I often hear is, hey, we don't have this level of concurrency. We don't have so many users using the system. And the point I want to make here is, if you solve the first 2, you will end up having the concurrency problem. This is exactly what we saw at LinkedIn as well. When we first launched it, when the latency was bad, when we didn't have the real-time analytics, very few people were actually accessing who viewed my profile. But once we changed that, we had tens and thousands of people accessing this page. And that's where concurrency comes into picture. So how does Pinot achieve all these things? One of the things that we realized when we were looking at most of the databases were most databases try to solve this in the traditional way, which is you have this data, you use something like columnar store, vectorization, SIMD, all these classic techniques. But at the end, they were trying to do the same work faster. And that's what we had to rethink, and we had to come up with the new ideas. Our philosophy here was, can we avoid this work in the first place? And that's the power of indexes with Pinot. We try to avoid this work if possible. And by doing less work, we are able to achieve more concurrency and make sure that the latency doesn't scale linearly with the concurrency or with the data size. In fact, we have indexes for every use case, every query pattern. The classic inverted index, we have the StarTree index, even geospatial index. Today, if you open up your apps and then if you're looking at orders near you, that is actually leveraging the geospatial index. We also have the ability to search within the JSON nested data structure as well. So the key highlight here is you want to make sure that your database latency doesn't scale linearly as you add more data points or as the concurrency increases. The other point that I want to make about the databases today is we saw the graph on the left side where the value of a single event reduces over time. But the flip side of that is the value of your aggregated data, they increase over time. So what happens in most organizations is they end up using one databases for your raw data and another for the aggregate data. This is where Pinot has this concept of StarTree index, where it provides a single abstraction both on your raw data as well as your aggregate data, and then efficiently be able to query both of them in real time. So with this, you can have one database that allows you to serve multiple use cases. It not only helps you with the operations, but it also avoids the problem you have with consistency, where when you have multiple systems, maintaining the consistency between them becomes another challenge. Last but not the least, it's about the cost and performance trade-off. If you look at the query frequency, typically most of us query the most recent data. And in fact, you see this curve of the query frequency being very high for the most recent data, but as the data ages, the query frequency goes down. But that leads us to the question of should the systems be tightly coupled or decoupled? That's another amazing feature that we added with StarTree on Pinot, where you can choose this trade-off. You can pick how long you want the data to be local, where you actually run this in a tightly coupled mode, and after X number of days, it can actually be moved directly to the S3. And Pinot has this ability to directly query the data in S3 and then be able to serve your queries. The key point that I do want to highlight here is this is not lazy loading. This is not that when you get the query, we pull the data from S3 and then serve the queries. This is on the fly. It is making sure that it accesses only the data that it needs from S3, and it also leverages the power of indexes that we have. So this is amazing because it gives you kind of the ability to trade off between cost and performance for various different use cases. You can configure it at a granularity of time or data sets or even get to a column level. With that, I'm super proud to announce the availability of the StarTree Cloud. This will help you simplify the option for you in terms of deciding Pinot and how to consume it. And this will also allow you to experience the power of Pinot with ease. Let's take a quick look at this. We provide a self-service portal for all of us to quickly sign on, be able to create your account, your workspace, configure your cloud providers, be it AWS, GCP. We also have Azure coming up very soon. You can also pick multiple availability zones here, So this allows you to make sure that you have fault tolerance in place. And once you have that, you can configure your network as well as your IDP. It can be Okta or GitHub or any of them. And then, boom, off you go. Within minutes, you have your entire Pinot cluster set up for you, and you're able to get the data in and then query it. And the nice part about this is you can consume it the way you want it. We provide multiple options for you to consume this, be it the traditional, the most common public SaaS model, where the data resides in the StarTree network, or you also have the BYOC, or the private SaaS, which we refer to as the bring your own cloud model, where the data doesn't leave your network. It always stays within your data plane, within your network, but at the same time you get the benefits of SaaS, where we manage and operate your deployment, make sure that we take care of all your SLAs requirements as well. Not only that, this model also comes with additional apps like Pinot Control Panel that allows you to run Pinot as a service within your organization. Once you have the environment, we have even made it super easy for you to actually interact with the data. Not only that, even ingest data from various sources. So as you see here, you can ingest data from SQL sources, streaming sources, or even batch sources. Once you get the data in, we also provide various apps on top of it. For example, Third Eye, which is an anomaly detection and root cause analysis app. The idea here is, as soon as you get data into Pinot, you can extract the value out of it immediately. Last but not the least, we also have APIs that you can use to connect to your favorite BI tools, as well as build your own applications on top of it. I'm so happy to have these customers help us to get to this stage. And these are the customers who have leveraged StarTree for the real-time and user-facing analytical use cases. As you can see here, we have customers across various sectors, right, and also various sizes of companies. And they're all beginning to leverage real-time and then be able to deliver exceptional experience for their customers. To conclude, I want to call out that real-time analytics is no longer a nice-to-have. It's a must-have for all of us. And embracing this is crucial for all organizations to not only stay competitive, but also deliver exceptional user experience. But don't worry, we are here to help you make that leap. And not just that, we are even here to help you make sure that you're prepared for the future, where machines and AI will be part of the next decision maker, and they will play a very crucial role. I have seen many organizations that have gone through this transformation, but I can assure you one thing. Once you experience the power of real-time analytics and taste Apache Pinot, you're not going back. Thank you.